Okay, so first one we'll take a look at is graphing 3 cosine x plus pi. So this is a multi-step because it has 2 transformations in it. And what kind of transformation is the 3?
Vertical stretch?
Yep, so vertical stretch. And what kind of transformation is the plus pi?
Phase shift?
Yep, phase shift or horizontal stretch. So the first step to graphing it is to make a table.
I thought that was horizontal shift.
Phase shift is horizontal shift.
Okay.
Yep, those mean the same thing. So we're going to make a table. Inside the table, we're going to put our final answers. Outside the table, we'll put the original values. What are the original x values for cosine?
0,
Okay.
pi over 2, pi, 3 pi over 2, 2 pi.
And what about the original y values for cosine?
1, 0, negative 1, 0, 1.
Yep. Okay. So now we've got to figure out what we're doing to all of them. Let's start with the x's. So we've got a plus pi, which means we're going to do what kind of arithmetic to all of these?
You're going to add pi to every. So you're going to add.
We are going to do something with pi, but
Shift it to
we
the
don't
left.
add it. Yeah, we want to shift left, so that means the x's need to get, if they move left, what's happening to the x's?
You subtract pi from each of the numbers.
Right, they're getting smaller, so we have to minus pi from all of them. Okay, so let's start, what's 0 minus pi?
Negative pi.
Negative pi. And we can do the common denominator, or if you already know, what's pi over 2 minus pi?
Negative 1/2.
It still has to have pi in it somewhere.
Negative 1 over pi.
So we've got pi over 2, and we're subtracting pi. But pi doesn't have a denominator, so what could we put?
1.
Put a 1. And then what's the common denominator between 1 and 2? 2. So how would you make this a 2?
You multiply the numerator and the denominator by 2.
Yep, multiply them both by 2. And what's 1 pi over 2? Take away 2 pi over 2.
Negative 2 pi over 2.
Yep. So that's the second. The third x value, what's pi minus pi?
0.
0. And then 3 pi over 2 minus pi.
Pi over 2.
It's going to be pi over 2. And 2 pi, take away 1 pi.
Pi.
Pi. Okay, so there's all your x's. Now the y's are going to change too because of this 3. What do we do to all the y values?
You are going to multiply them by 3.
Yes. So we're going to times all of these by 3, and those are my new y values. So what will I get for that column?
3, 0, negative 3, 0, 3.
Okay. So now we're going to make the sketch, okay, but that's the table. Any questions on the table?
No.
Okay. So let's get a piece of graph paper. I'm gonna move that down and just try to make the graph a little bigger. Okay, so we need to make sure that we have 2 labels on the negative part of the x-axis, and then everything else is 0 or higher. So let's put negative pi right there. Then we'll do negative pi over 2, 0, pi over 2, and pi. Okay, what's the highest y value that we need?
3.
And the lowest?
Negative 3.
Negative 3. So what I'm going to do is I'm going to go by 3s on my y-axis. So this will be 0, this will be 3, and that'll be negative 3. Okay, so now we just graph our points. So we've got negative pi, we're at 3. Negative pi over 2, we are at 0. Zero, negative 3. And then what about when we get to pi over 2?
Pi over 2 be 0.
Back at 0. And pi?
3.
3. And we draw it just like that. Any questions on the sketch or the table?
Nope.
Nope. All right, so next question we'll take a look at is finding the period of a function. For sine and cosine, we use the same formula. And what's the formula that we use to find the period?
T equals 2 pi over b.
Yep. And where is b located?
4 in front of the x.
Right, it's whatever's in front of the x. So the first one would be 2 pi over 4, which would reduce to
1 pi over 2.
1 pi over 2. So that's the length that you have to travel on the graph before it repeats itself. Pi over 2. Okay, how would you set up the one below it, cosine 1/2 x?
Would you do 0.5 over it? Or 2 pi over 2 pi over 1/2.
Yep, and when you divide something by a half,
You're multiplying it by 2.
that's the same as doubling. And what would you get when you do that?
You get 4 pi.
4 pi. Yep. And let's look at the last one. How would you figure out the period of sine pi over 2x?
Would you divide by pi? Divide by pi over 2.
So what would your fraction be?
2 pi.
2 pi.
Pi over 2.
Divided by pi over 2. And dividing by pi over 2 is
Okay.
the same as...
Canceling out, so you just 1.
So let's just write it out just to make sure we know what's what. So how would you write this as multiplication?
I don't know.
So what, 2 pi, let's start with writing that as a fraction.
Oh, would you multiply it by 4?
How could you make 2 pi a fraction? Because it's not right now.
2 pi over 1.
Okay, so 2 pi over 1, and we're dividing it by pi over 2. So you have a fraction divided by a fraction, which is complicated. So what do? Instead of dividing by a fraction, you multiply by the reciprocal, which in this case would be
2 over pi.
2 over pi. And what's going to happen when you multiply those together?
4 pi over pi.
Okay, so 4 pi over pi, and it simplifies to 4. Yep. So that's the length of the period for this graph, 4. Okay. Any question on finding the period of those? All right. Okay, so next one we'll look at is finding amplitude. So the first one we have is y equals 3 cosine 2x. And what would the amplitude be there? 3. Amplitude is the absolute value of the number in front. This 2 has nothing to do with the amplitude. It's a period change. It would affect the period, but it doesn't affect amplitude. How about the amplitude of the next one?
Still 4.
That would be
Absolute
4.
value.
Yep. The plus 1 and the minus 5 have no effect on the amplitude, and the negative has no effect. They do have an effect if you were to draw it, but they don't affect the amplitude. Any questions on that? right, so next two questions we'll look at. These are both solving trig equations graphically. And let's start with the one on the left. Okay, if I want to solve that, what would I put in y1?
Sine x.
Yep, so sine x. And y2?
0.3.
0.3. And now we have to set our window. And normally we do zoom 7 unless they tell us another window, and here they are. What are these? Where would these two values go on my calculator?
X min and max.
Right, they're giving me an x min and max. So I want to put in 0. I already have 2 pi put in, so everything's all set. And what mode do we know we have to be in for this question? Because there's 2 modes. Yeah, we want to be in radians because the information they gave us is in radians. The way I would know it's degrees is if they had a degree symbol, like right here, and a degree symbol over here. If they don't have those degree symbols, we're in radians. Okay, so we've got everything put in. We've got our window set. What's the next thing we got to do? Yep, we can go to the graph. So there's sine x, there's 0.3. And how are we going to figure out where they are equal?
7 cal.
Yep.
And then 5.
Yep, intersect. And does it matter where we put the guess?
Yes.
Yeah, because there are 2 different points. So wherever you put the guess, it's going to give you that answer, whichever one you're closer to. So I'll do the one on the right first. Okay, so we get about 2.84. And we got to do it again. Second calc intersect. This time just move your cursor until you're closer to the one on the left. Just like that. And that gives you 0.30, yeah, about 0.30. Okay, any question on that one? So the way you'd write your 2 answers is exactly the way they are here. X equals, X equals. Okay, let's look at this one. What would go in y1 this time?
Sine 2x.
Sine 2x. And y2?
Cosine x.
Cosine x. Window is exactly the same as last time, so we don't have to adjust it. And how many answers would we get in that window?
5. 4.
4, yeah. We get 4 different answers. 1, 2, 3, 4. And we'd have to do second calc intersect for each one of them. Any question how you would do the intersect 4 times to get all of them? Okay. Any questions on how to solve trig equations using the calculator?
Will there be inequalities or just equations in the quiz?
I think just equations.
Okay.
Yeah.
No question.
So last one we'll take a look at is solving another trig equation. But I want to write down an exact answer for x, and I want it in radians. So let's just start doing it and see what happens. Okay. What goes in y1?
That would be 1/2.
1/2, or 0.5. And what would go in y2?
Sine of x.
Sine of x. Now we want to set the window from 0 to 2 pi. We're already all set. So let's hit graph. Okay. And I specifically want the exact answers. How many answers are we going to get?
2.
We get 2. Now, what mode is my calculator in right now?
Radians.
I'm in radians, and that's the mode I should be in because that's what they gave me. If I do second calc intersect, I get 2.6179. Is that an exact answer?
No?
No, that's a decimal. That's rounded. That is not an exact answer. Okay. Let's check the other one. Second calc, intersect. 0.5235. Is that exact? Nope, that's another decimal. I'll put it here, I should have put the other one back. We'll keep that one up here to remember that was one of the answers. But it's not exact. If I want you to get an exact answer, then when you do the problem in degrees, it will come out nice. So let's do it in degrees. And then if we want radians, we will convert our answer by hand to radians. All right, they said 0 to 2 pi. What would that be if I did degrees?
360.
0 to 360. And what else do I have to do?
You convert your zero.
Something on the calculator.
Go to
So what are we trying to do the problem in now?
is it second calc intersect now?
We're going to do intersect, but we have to change something on the calculator. Because before we got the answer in.
Oh, you have to change the 2 pi to 360
Yep, we did that. And why did we do that?
because you're changing radians to degrees.
Right, we're trying to do the problem in degrees. So what else do I need to change on my calculator?
So you zoom.
Well, we're adjusting that by changing the window. We have to change the mode.
Oh, okay.
We're still in radians. If we don't change that to degrees, we're not going to get it in degrees. So how do we put that in degrees?
So second, is it you hit mode? Right?
Mode.
And scroll down to radian degree.
Yeah. So we're going to change it to degrees. And when we graph it, we get the exact same picture. The axis looks a little thicker, but that's fine. It's the same picture. Let's get the answer to this one now. Second calc intersect. 30. Is that a nice number?
Yes.
Yes. So we got an answer of 30. And just to make sure we know which one is which, this was radians, this was degrees. Now let's take 30 degrees and fix it by changing it to radians by hand. And we'll be able to get the exact answer. What do you multiply by to change degrees to radians?
Pi over 2. 180 divided by pi.
So it is pi. And then over, what goes in the bottom?
180.
180, yep. What cancels out completely when we multiply there?
The degrees.
Degrees is gone. And what number goes into 30 and 180?
30.
30. How many times does it go into 30?
1.
And how many times does it go into 180?
6.
6. What does that leave you with?
Leaves you pi over 6.
Pi over 6. Let's take pi and divide by 6 and see what it comes out to. Pi divided by 6. 0.52359877. 0.52359877. It's that number. That's how you get the exact answer. You do the problem in degrees first, and then change it to radians by hand. And this will always happen if I ask for the exact answer. You'll always get a nice answer in degrees. If you don't get a nice answer in degrees, and you don't get a nice answer in radians, then I would not ask for that.
Okay.
And you do the same thing for this one. Okay? If that's asking for exact, it must come out nice. Second calc intersect. And does the second one come out to a nice answer? Yep. Comes out to 150 degrees, and you would change that to radians by hand.